Hello students, I welcome you all to Brilliant Public School's online channel. Today we will discuss Chapter 7 Coordinate Geometry of Class 10th Mathematics. So let us start. First of all, coordinate geometry means we need to understand what is a Cartesian plane. So here is your Cartesian plane where both the axes meet. That point is called origin. So that you people very well know, it was there in class 9th as well. Now these are your four quadrants. You can see first, second, third and fourth. And if we want to plot any point in any of these quadrants, we need to understand the signs. So both are positive in first quadrant. In second quadrant, x is negative, y is positive. Then in third quadrant, both x and y are negative, and in the fourth quadrant, x is positive and y is negative. So basically when we try to write any point, we write in this manner, p x comma y, where p is the name of that point. Also we know x is the abscissa, which is the x value, we say abscissa, and y value is ordinate. And we very well know together we say these are the coordinates of point P, x and y. Moving right now, I told you about the points and coordinates. You can see here I have three different points. Point A, B and C in three different coordinates. It is also shown in point B, the first value which is -3 is your abscissa and the other value is -2 which is ordinate. So here basically you need to understand, we need to check the signs of the numbers and accordingly we will plot. So a question for you is that what will be the coordinates of point C? Do write in the comment section. Moving on to the important part of this chapter, which is the distance formula. Here the concept is we need to find the distance between 2 points where it is P whose coordinates are x1 comma y1, and for Q it is x2 x1, sorry, it is wrong, it would be x2 comma y2. Then if you will see it properly, if I want P, here you can see whatever is this length of PT, that is length of RS as well. So you can see for point R it would be x1 only because its y value will be 0. You can understand if a point is on x-axis its y value will be 0, and here when it is on y-axis its x value will be 0. So here you need to understand one important thing, that if it is x1 and this point R, point R is x1 and point S is x2, what will be the length of this RS? So I can guaranteed say it would be x2 minus x1. Okay. Also, when I need to find the length of this QT, I need to understand in a simple manner. It would be y2 minus y1. So that is the sense I have to consider this triangle. So I have the base of this triangle which is x2 minus x1. I have the perpendicular of this triangle which is y2 minus y1. Now the point is the hypotenuse. So you can see by applying Pythagoras theorem in that triangle, we will get this hypotenuse square equals to perpendicular square plus base square, and after applying this we can definitely reach to this point, that distance between any two points whose coordinates are x1 y1 and x2 y2 will be this root over x2 minus x1 whole square plus y2 minus y1 whole square, and this is the important formula, we say distance formula. Any distance of the point from the origin is root over x2 minus x square plus y square. You can simply take it as, because we very well know if we are talking about origin, the coordinates of origin we very well know the coordinates are 0 comma 0. So no doubt the other point if we are taking as x comma y, which is point P, So the distance between them will be clearly the square of those two numbers. So the distance would be equal to root over x square plus y square. Now the important thing where we can use distance formula. So we can find the length of the sides of the triangle. You can literally find the sides of the triangle, and no doubt if you know what is the length of the side, what is the distance basically. So we can identify what type of triangle it is. Either it is equilateral triangle or isosceles triangle or scalene triangle as well, if we know the length of its sides. The same logic is applicable for a quadrilateral as well. Only difference is that we need to find the length of the sides of the quadrilateral, the four sides, also the diagonals. Okay, because if I will say all sides equal, so there are two possibilities. All sides equal, that means it could be square or it could be rhombus. So I have two options, square and rhombus. But there is one simple difference. If the diagonals are also equal, it would be square. But if the diagonals are of different length, it would be rhombus. So along with the sides of the quadrilateral, we need to find the diagonals of the quadrilateral as well. Also, we can use this to find if the 3 points are collinear or not. For an example, if I have a line and in that I have 3 points A, B, and C. So obviously, whatever is the distance of AB plus the distance of BC should give me the distance of AC. If this property is true, I can say the points are collinear, they are lying on the same line. And if the sum of the two line segments AB plus BC is not equal to the length of AC, so I will basically reach to a conclusion that they are non-collinear points. One more important formula in this is the section formula. Basically, when we have a point P which divides two of the points. First point is A whose coordinates are x1, y1. Other point is B whose coordinates are x2, y2. So if point P is dividing those 2 points in the ratio m1 and m2. So if I want the coordinates of point P, those value of x and y, I will use this formula to find the value, which is m1x2 plus m2x1 divided by m2 plus m1. Same for y value, which is the ordinate m1y2 plus m2y1 divided by m2 plus m1. Here is the geometrical representation of the definition of section formula, where you can see point A is x1, y1, as I have told you, it is one of the points, and point B, the coordinates are written here, x2, y2. And if I want to find the coordinates of point P, this is the formula, and m1, m2 is the ratio in which point P is dividing A and B. Now, where to use this section formula? So there are different ways where we can find. If we have to find the midpoint, so we can use with this formula. Also, when we need to find the centroid of a triangle in center. So in this two or three conditions, we can majorly use section formula to find the coordinates or to find the ratio or to find one of the point. So the things depends on the type of question we have. Thank you so much students for watching the video.